Hey everybody, and welcome to the last online lesson of the school year, and hopefully we'll be getting back to the groove of things next year. But as you can tell, we're jumping into 11.5 volumes of cones and spheres. Forgive all the paint and stuff on my thumbs and fingers. Sorry about all that. But anyways, we are moving on from chapter 10, and we're going to cover one section in chapter 11. We're going to be doing volumes of cones and spheres. I just sent out an email that was talking about after this lesson and after this assignment, you guys are going to have one more test for the year. It'll be the chapter 10 and chapter 11 with volumes of cones and spheres attached to it. So it's going to be the chapter 10 test with volumes of cones and spheres. That is going to be due Wednesday at 3 p.m. That's next Wednesday, not this Wednesday, but Wednesday the 20th at 3 p.m. Both the test and this assignment are going to both be due by that date. So make certain you get this done as fast as possible, and then the test as well. Again, you can take the test as many times as you want, and I'll keep only the highest score. Those will be the last opportunities to improve your guys' grades for second semester. So let's jump into it, okay? We're going to find the volume of a cylinder that has the radius of 8 centimeters and a height of 4 centimeters, okay? So this is a part of the lesson that we haven't covered yet. We're jumping into 11.5. So there's one aspect of a cylinder. So a cylinder is a three-dimensional object that has a circle on the top and the bottom. So that would be a cylinder, okay? The volume of a cylinder is you take pi r squared, which is the area of the bottom, and then you multiply it by the height, okay? So we're going to take this pi r squared and multiply it by h. So the volume of a cylinder that has a radius of 8 would mean we would plug in a radius of 8 and a height of 4. 8 squared is 64, and 64 times 4 is 256. So the volume of this cylinder would be 256 times pi, and that'd be in centimeters cubed. Now, the difference of a cone. There's a difference between a cylinder and a cone. A cone still has a circular base to it, but it gets smaller and it comes to a point in the center of the circle on the top. So there's one difference between the volume of a cylinder. Now this is not going to be on the test. The volume of a cylinder is not going to be on the test, but a volume of a cone will be. The volume of a cone is you take the volume of a cylinder and then you divide it by 3. So the volume of a cone is the area, this capital B here, is the area of the base. In this case, the base is a circle. Okay, so it's the area of the base, which is a circle, which the area of a circle is pi r squared. So it's pi r squared times h, and you divide that entire thing by 3. So that's right here. Volume of a cone is pi r squared h divided by 3. So you find the volume of the following cones. So volume is going to equal pi times the radius squared times the height divided by 3. Now the height must be perpendicular to the base. Okay, it must meet the base at a 90-degree angle. So the 1 centimeter here would be my radius, and the 3 centimeters here would be your height. Your radius and your height. Okay, so the volume is going to be pi times radius, which is 1, squared, times the height, which is 3, divided by 3. 1 squared is 1, 1 times 3 is 3, but 3 divided by 3 is 1. So this all leaves us with just pi. The volume is exactly equal to pi for this cone. Now it tells us up here, first leave your answer in terms of pi, which we've done. This is our answer in terms of pi. And then it says, then round it to the nearest tenth. Pi is equal to 3.14159265358979323 but we don't need all that. All we need is 3.14. So pi is approximately 3.14, but this 4 moves that 1 and keeps it a 1. So our first answer is pi centimeters cubed. And our second answer would be approximately 3.1 centimeters cubed. That's our answer in terms of pi, and this is our answer rounded to the nearest tenth. Let's try the next one. So this one is a slanted cone, but that doesn't matter because it gives us what our height is. This height, which is perpendicular to the base, is 3. So this is our radius, and this up here is our height. We have our radius and we have our height. So the volume is going to equal pi times radius squared times height, all divided by 3. Which, when we plug all those in, we have pi times radius, which is 2, squared times the height, which is 3, divided by 3. 3 divided by 3 is 1. Those go away. 2 squared is 4 pi. So our first answer would be 4 pi centimeters cubed. That'd be the exact answer in terms of pi. First leave it in terms of pi, then round it. And 4 times pi is 12.56. So it's 12.56. The 6 is going to move the 5 up. So our second answer would be an approximate sign, 12.6 centimeters cubed. Oh, no, not centimeters cubed. Whoop. Meters cubed. That's in meters, not centimeters. Meters. So just an M, not a cm. All right. This one asks us to work a little bit backwards. It's going to tell us what the volume is, and it asks us to use algebra to find out what the radius is. You still start with the exact same equation. Volume equals pi r squared times h divided by 3. But instead of them telling us what r is and what h is, they tell us what v is and what h is, and they want us to find r. So the volume is 21 pi. So that goes in for volume. Then we have pi radius squared times height of 7 divided by 3. So now we use algebra to solve. We multiply the 3 over. 21 times 3 is 63. So we have 63 pi equals 7 pi radius squared. Now I can divide by 7 pi, and I divide by 7 pi. The pi's go away. 63 divided by 7 is 9. So we have that 9 equals radius squared. Take the square root, and you get that the radius is 3. So that would be giving us the volume to find an unknown value. And I guess actually technically we should call this x equals 3 because they call the radius x. So at the very end we could just call x equals 3 and that would be our answer right there. All right, so that's cone. Let's flip the sheet over or go to the next sheet. And now we are going to talk about volume. Volume of spheres, of balls. Okay, volume of a sphere. Here is your formula. This is what you need. You can use this sheet when you take your test. You can use this sheet when you do your assignment. Volume of a sphere is 4 divided by 3 multiplied to pi r cubed. Volume is equal to 4/3 pi r cubed. So again, first leave your answer in terms of pi, then round it to the nearest tenth. So we use the formula, 4/3 pi radius cubed. Plug 5 into the radius. Volume is equal to 4/3 pi times 5 cubed. So technically, all you got to do now, so we have to reduce this. So we have to take 5 and cube it. 5 cubed is 125. So that's 4/3 pi times 125. Multiply 125 by 4/3. Make it a fraction, and you get 500 over 3. So it's just multiply 4 times 125. So it's 500 pi divided by 3. And that would be in feet cubed. That would be our first answer. That would be our answer in terms of pi. We would do our approximate answer, and we'd use our estimation sign. Nearest tenth. So you take 500, you multiply it by pi, and you divide it by 3, and you get 523.59. The 9 makes the 5 become a 6. And again, that'd be in feet cubed. So our answer in terms of pi, our answer rounded to the nearest tenth. This is a little bit different because instead of giving us the radius is from the center of the sphere to the edge. They give us the diameter. They go edge to the center to the edge. That's called the diameter. So if the diameter is 15, the radius equals the diameter divided by 2. So the radius is going to be 15 divided by 2. So we have volume equals 4/3 pi r, which is 15 over 2, cubed. So you take 4/3, which is 4 divided by 3, and we multiply that by 15 divided by 2 cubed. You get 562.5, make it a fraction. We like fractions in this class. 1,125 pi divided by 2. And then that would be inches cubed. And that would be our exact answer. That would be our exact answer in terms of pi. If we wanted to then figure out the approximate answer, we just take that, plug it into our calculator, and you get 1767.14. The 4 keeps the 1 a 1. Okay, so the volume would be approximately 1767.1 inches cubed. And there you go. Exact answer in terms of pi, nearest tenth. A word problem, and then we're done. Well, for this lesson. A spherical balloon has a 14-inch diameter when it is fully inflated. Half of the air is let out of the balloon. Assume that the balloon remains a sphere at all times. It's always a sphere. Find the volume of the fully inflated balloon. Fully inflated balloons in terms of, that should say pi, P-I, or it should have the symbol pi. Sometimes when this gets flipped over to a PDF, it gets changed a little bit. But that should be a Pi or a pi symbol. Okay? All right. So the volume is going to equal 4/3 pi times radius cubed. So the fully inflated balloon has a diameter of 14. So if it has a diameter of 14, it's going to have a radius of 7. You have to take half of your diameter, which is 7. So it's going to be volume equals 4/3 pi times 7 cubed. So 4/3 times 7 cubed as a fraction is 1,372 pi divided by 3. That's our volume in inches cubed. And it says, keep your answer in terms of pi, so that's our answer in terms of pi. Now, here is where this one gets a little tricky. Find the volume of the half-inflated balloon. So some of you would think all we have to do now is divide this volume by 2, but that's not correct. You cannot just cut the volume of the one we just found in half, because in the sphere, what has to be cut in half is the diameter has to be cut in half. And that's going to completely change the volume of it. Okay? So we have to cut the diameter in half, not the volume. So we have to take the diameter, which was 14, cut it in half, which is 7, and then take half of that, which is then 3.5 to get, or you can just take the radius of our last one and cut it in half. So the radius of the half one is going to be 7 divided by 2. Taking the radius of the fully inflated balloon and cutting it in half. So then the volume is going to equal 4/3 pi times this radius cubed, which is 7/2. So you take 7/2 and you cube it and you multiply that by 4/3. You make it a fraction, and the answer this time is 343 pi divided by 6, and that would be in inches cubed. I think I just screwed up a little bit, guys. I apologize. I think I was supposed to take half of this, find the volume of the half-inflated balloon in terms of pi, find what is the diameter of the half-inflated balloon. I messed up. We needed to take half of this. Sorry, everything that we just did is my bad. I made the mistake of what I was trying to not make the mistake of. We need to just take half of this volume. This is where I was getting to, is this question down here. So this is totally my bad. Forget everything we just did there. We need to take half of this volume. So we'd have volume is equal to 1,372 pi divided by 3, and we need to take half of it. So multiply it by a half, which then really just takes 1,372 divided by 2 is 686. 686 pi divided by 3. So that would be the volume of the half-inflated balloon. This is what I was trying to not do, and then I totally did it. My brain was somewhere else. I apologize. Okay? What is the diameter of the half-inflated balloon? Many of us would think that the diameter of the half-inflated balloon would be half of the 14, which is 7, which would be then 7/2. But that is what is not correct. Okay? The volume is this. So now we need to set this volume, which is 686 pi divided by 3. We need to set that equal to 4/3 pi radius cubed. Solve for r, double r, and we get the diameter. So 3 goes away on each side. Multiply by 3 and they both go away. Divide then by 4 pi. Divide by 4 pi. The pi goes with the pi. And you have 686 divided by 4, which is 171.5. And that equals radius cubed. And now we got to just take the cube root. The cube root. I'll show you where the cube root is on your calculator if some of you don't know. Okay, the cube root is you go under math, and it's the fourth one down. It's this one right here, the cube root. It has a little 3 above the radical sign. Okay, so it's the fourth one down after you press math. So I'm going to do the cube root of 171.5. Getting 5.55, call it 5.6, which is about 5.6. So now we will double this. That's our radius. So our diameter is going to then be about 5.6 times 2. And 5.6 times 2 is 11.2. It says round it to the nearest inch, so we call it just 11. So here is what I was trying to say. And I accidentally said the exact opposite of what I meant to say. Okay? We think that the diameter would just be cut in half. But if you cut the volume in half, it does not cut the diameter in half. The diameter went from 14 inches down to about 11 inches. This, what I did here, is all wrong. That was my pretending to make the mistake that most kids think to do. If you take a balloon and you cut it in half, the volume of it, you do not cut the diameter in half. The diameter goes from 14 inches to 11 inches, which is not half. Wow, I feel bad that I made that mistake there at the very end, but that's all right. Fixed it. Mistakes happen. You move on. So, we are done with the online learning portion of this semester. There are 2 assignments, 2 things you have to get done for the rest of this semester. There is the volume of cones and spheres assignment on Math Excel. Then there is a test on Chapter 10 and the volume of cones and spheres. Both of these are already available. Finish these notes, do the assignment first, then do the test. The test and the assignment are both due again at 3 p.m. next Wednesday. The best score that you have at that time will be placed into the gradebook, and I will be able to calculate all of the final grades for second semester at that time. Thank you all very much for however many of you are still listening to the end of this video. And I will hopefully see you next year. Come and say hi. All right. Bye, guys.